Welcome. And what kind of tea do you like? Green tea, black tea, or pink tea? Okay. Welcome to week 8 for General Biology 1. And for this topic, this is going to be, I would say, a special talk because it gives you an overview about light. So we're just gonna go back as a sort of review. We're left with this one, the ATP cycle, as you can see it. And when you go down, it talks about chlorophyll and other pigments. And technically, we are going now with how plants generate their energy source. Okay, so for this topic, this basically focuses on white light. White light. There are other colors of light, I suppose. Okay. Oh, sorry. Let me just go back to that one. Okay. And in here, when you go down, it talks about light. Okay, so we'll just use this. Okay, now there are other types of light. Okay, and this is based on a electromagnetic spectrum, uh, EM spectrum. So you have gamma rays. This is how Incredible Hulk got his power. Okay, X-ray, which is quite common. We use it in the hospital to see bones and other parts of your body. UV light, ultraviolet light, which on a very extent of a higher extent, it may damage some part of our body. Okay, and there is a tiny fraction of visible light. Okay, and another name for visible light, I hope they mention it. Okay, they just call it visible light, but it is also called white light. Okay, now I would actually love this to be like an experiment class. Like while doing the experiment, I'm gonna be discussing. So I'm gonna be asking one of your classmates to take the diffraction glasses, diffraction gratings. I have some on my cabinet, and if not, you need to go ask your physics teacher, Sir Caboral. He has a collection of diffraction glasses, but if not, I think I have it. So I'll ask somebody from the class. Okay. So this time we're gonna use our imagination. I wish we could set up our classroom wherein we would close the windows, but for this time, we'll just have to imagine. Okay, closing the windows, closing the doors. It's gonna be air conditioned. Okay, so don't worry. And of course, close your eyes. Okay, I hope you are imagining closing your eyes. Not imagining, you're doing it. Okay. And what you need to imagine is that I'm gonna turn off everything, starting from the light source in the room. And then I'm gonna turn off the light source outside. And we'll just imagine that it's nighttime and I'm gonna turn off the moon, turn off the sun so that there's gonna be no moon and everything, all the source of light. Now, what do you see? Okay, what color do you see? If all the light in the universe are in the world, okay, what color? Is it green or black? That's why I'm having this one. Okay. I hope you're saying or you're thinking that, Oh, everything is black actually without light. Okay, and that is totally true. And having that in your mind, what gives color then? Okay, why do we see red, orange, yellow, green, blue, indigo, purple, and a mixture of those colors? That is actually because of light. Okay, we see colors because of light, but we always think of light as hmm, light is just white or yellow commonly. Okay, so let's start now. So we see colors because of light. Okay, and I flashed it already a while ago. Okay, there you go. Okay, electromagnetic spectrum. Okay, we commonly call this as visible light. These are the light that we can see in our eyes. Okay, coming from where? Coming from the light. Okay, and you have this colors you see over here. Okay, you need to remember this. Okay, red, orange, yellow, green, blue. Oh, we're missing indigo, and there should be violet. Okay. So remember this as your mnemonics. Roy G Biv, B-I-V. Okay. So how do we see this? Okay. Who told us, by the way, that the light, okay, the light from the sun. Oh, okay. Sorry. I'm not gonna reveal this. Okay, but yes, yes, yes. You are supposed to use your diffraction glasses. Okay, there are different types in there, and we are going to observe after the discussion. After going to observe different sources of light. Okay, and ideally you can use if you have a series light that has so much colors, that would be best. And of course, ideally everything should be black with your diffraction gratings and see what kind of colors would you see if you have yellow light from the candle, a white light from flashlight. If you have a lighter, yes, you can use that. You can use the fluorescent light. And of course, finally, you need to go outside and look at the sun and tell me what color you see in there. Okay, so I need you to do it in class. So once again, it's nice if you use a series light that has different colors. So you would see what are the range of colors you can see in there. Okay, so like different wavelengths of EM waves, this wavelength of light and others make up the spectrum, but we're just gonna focus on visible light, or we call this the white light. Okay. So these are just technicalities of the white light. Okay. No. The electromagnetic wave, EM wave. Okay. And this is what the visible light or white light. Okay, it's considered white light. Waves we can see. Now, what do you see here? You have here a prism, and with light hits the prism, okay, it breaks the color into Roy GB. Again, it should be Roy GB. And who was the person who discovered this one? Now I need to stop share and go to the biggest library. Okay, they claim to be the biggest library in the whole world. And this is from the Smithsonian Library. Who discovered this one? The science of color. Okay. And of course, you have there Isaac Newton. Okay. Newton's rainbow. Okay. So we basically see rainbow That's because um, the the droplets of rain reacts or works as your prism, which breaks down the light into seven colors of the rainbow, hence your Roy G. Biv. And in Newton's case, okay, in 1660s, English physicist and mathematician began his use with sunlight and prism. Clear white light. Okay, so here goes. White light was composed of seven visible colors of the rainbow. Also, I would like to promote Smithsonian libraries because they have so much in here. Okay, and what is Smithsonian? Is the world's largest museum, education, and research complex. Okay, so visit this site, and there's so much you can see in here. Okay, I haven't explored much, but there is a lot, and there's so much to see exhibitions. They also have online books that you can use. Okay, so let me stop on that one, stop share, and go back to our slide. So you have your visible light, which is which are composed of Roy GB, the seven colors of the rainbow. Okay, the visible spectrum contains seven colors. That's what you see in there with a particular wavelength. And even with those colors, okay, they have a particular wavelength. And you talk about X-rays, these are the wavelength of light wherein it could penetrate our, our body. Okay, longest, shortest. How can I remember the seven colors of the rainbow? Oh, they're there. Okay, I told you already. Roy G. Bibb. So red, orange, yellow, green, blue, indigo, and violet. Okay, I'll just flash it quickly. So please remember that. Okay, white light is not a single color. Okay, like what I said, the sun and the light that we used at home is actually not a single color, but a mixture of technically the seven colors of the rainbow. Okay, now this is how we could use this. I'm not sure if we have a prism in class. You can try to do it if we have it. Okay. Now, as I explained already, this is how we see a rainbow. Now, the question now is that why do we see color? And if we have to relate this to photosynthesis, why are the leaves green? Okay. So when our eyes see different wavelengths of light in the visible spectrum, we see colors. And how do we see it? Daghan mo na ito nga color. Okay? What we actually see is the light an object reflects, or in some cases, the light an object produces. But we will stick with the term reflection and absorption of light. Now, what do we see here? Okay, when a white light hits this one. Okay, what color do we see? We'll just call it a red notebook. Okay, remember that the white light is made of red, orange, yellow, green, blue, indigo. Now, why do we see this as red? Okay, it is because, okay, this particle of the notebook itself absorbs which color? Okay, which one is absorbed? Everything is absorbed. Oi, GB, and reflects what color? Red. That's why, okay, we see it red. Okay, this one, I do not get this, so we're just gonna skip to that. Okay. Now, an absorption, the disappearance of an electromagnetic wave into the medium. It is the opposite of reflection. Now, I mentioned already, okay, that if It's supposed to be seven colors, but then all the six colors are absorbed, OI, GBIV, and only reflected which color? Reflected only red color. And the red color goes to our eyes. And this is why we see colors. Okay. Absorbs. Okay. The term is absorption or reflection. Absorbs OI, GBIV and reflects what color? Okay. Now this one. Why do we see this as purple? But this one is tricky. Okay. Why do we see this as purple? Okay, when white light hits this particle of a pants, okay, it only reflects the purple color going to our eyes. That's why we see it. That's why we see the purple color. Okay. Now a white hat would be different. Okay. Disregard the other light over here. We'll keep it as purple because a purple is a range of this one. Sorry, not purple, but we'll keep it as violet. Okay, not purple. Red, orange, red. Roy GBI is absorbed and reflects only violet. We'll keep it like that. Okay, just to give one color. Now, a white hat. Uh-oh. Okay, so what do you think? Okay, now remember it is called white light or visible light. Now, what happens in a white hat? Okay, seven colors hit it, and still all the seven colors are actually reflected, meaning nothing is absorbed. Now, if you're going to ask me, what is my favorite color for the longest time? I love to wear white all the time, every time. Okay, formal. I would not care. Okay, if I could wear white, I would wear white, especially in the Philippines because, okay, it is so hot. Now, you see the science now. Okay, and I hope you understand the science that white light reflects everything. So you don't feel much of the heat. Okay, or the light source in there. Okay, or the heat in there for that matter. That's why I love white. Feels fresh. And you can attest to this one too, yeah? Compared if you're gonna be wearing black. Where's my black? Okay. Okay, black tea. Okay, black is in it. Okay, so I would love to wear white all the time, and it's very nice on the eyes and it's clean. Okay, now the problem now. Let's do the opposite. Okay, there's another scenario. Okay, this one absorbs everything and reflects red, and of course, blue absorbs everything and reflects blue. Okay, okay, these are just the scenario outside. Now, what about black? Ooh, make a guess. Okay, we have black tea here. Sorry. Okay, black cat for this matter. Okay, what happens with a black cat? When you see black, all of the wavelength are actually what happens? Everything is absorbed. Okay, this is why it feels hot when you wear black, and nothing is reflected, which is the exact opposite of white. Okay, everything is so black is a selfish color. It just takes everything. Okay, so that ends with the discussion of um, white light, visible light, absorption, and reflection of colors. So, like I said, please do the experiment. Experiment with all the sources of light, given that there is no other light source. So, if you could bring a box and do the series light, just one light you're going to insert one light red and use your diffraction glasses. Okay, please do remind me also that you're going to be doing this while watching or perhaps after this video. So let me just stop share. Okay, and we're going to be doing another discussion, talk to about photosynthesis. So this is it for this video. Happy learning!